Now, before we go into too much detail about how you can do things in the database using the Mongo shell, we have to talk a little bit about how MongoDB actually represents data and how you can understand how the Mongo shell interprets that data when it gets it back from the database. As you already know, MongoDB is a document-oriented database. What this actually means is that MongoDB's fundamental record type is a kind of nested dictionary of key-value associations. As a matter of programming language convenience, we map the documents that come out of MongoDB to objects in the programming language that can represent these kinds of key-value associations. In JavaScript, the type of object that represents these kinds of key-value associations is called a JavaScript object. So, for example, if I define the variable obj, obj, to be equal to A1, B hello, C apples tomatoes, then the value of the variable obj is suitable for use as a MongoDB document. What I mean by that is that we can take this JavaScript object and put it into the database for safekeeping. As it happens, though JavaScript uses a syntax that's very similar to the JSON syntax, in fact, JSON syntax was inspired by the syntax of JavaScript, MongoDB internally doesn't use this stringy syntax for storing or retrieving data. Instead, MongoDB uses a binary representation for the data inside of documents. The specification for the binary representation that MongoDB uses is given at bsonspec.org. We call our binary format bson, which stands for binary JSON, and in effect this is a serialization format that's designed to represent a superset of what can be transcribed in JSON syntax. The exact specification is given here. The basic data types that bson supports are, of course, a superset of those that JSON supports. Double precision floating point numbers, string values, where string means a sequence of validly encoded UTF-8 code units, embedded documents, that is to say, nested objects, embedded arrays, that is to say, nested objects whose keys are the integers 0, 1, 2, 3, etc., the Boolean values false and true, and the null value. These are the basic data types of JSON. But bson goes a little bit further by adding a binary data type, a data type called object ID, which is used for unique identification of things, a datetime type, which represents time since January 1st, 1970, a 32-bit integer type, and a 64-bit integer type, and a few other types which are mostly only used for internal purposes, such as regular expressions in the query protocol and timestamps for replication purposes. These data types, which go beyond the JSON specification, correspond to types available in various programming languages, or else have some sort of special handling in those programming languages. Let me show you what I mean by that. In the shell, we use the JavaScript language. The JavaScript language has support for numbers, which are interpreted as double floats, strings, which are interpreted as UTF-8 strings, arrays, objects, true, false, null, and so on. To represent an exact integer value in the Mongo shell, we provide a constructor. NumberInt gives you a 32-bit value and prints out using the constructor syntax so that you can cut and paste easily without losing any numeric precision. NumberLong gets you 64-bit integer values. And we support at least some arithmetic on these things as well. Though we might not exactly round trip without some loss of precision. For instance, adding two NumberLongs appears to give us a regular old JavaScript number, which will be a double precision floating point value when it gets back into the database. So be careful when you use programs in a language like JavaScript or Perl, which might not have the expressiveness or the type expressiveness to faithfully represent all of the types that MongoDB can store. Similarly, JavaScript's datetime types are represented with a JavaScript date object, which, for reasons having to do with esoteric details of JavaScript, we print out with the constructor we call isodate. This constructor always gets you a new date object with a particular timestamp inside it, which is somewhat different from what the apparent date constructor does in the JavaScript language. So to construct an object in JavaScript that contains numbers that are fixed precision integers, or that contain dates, such as the one that's currently on the screen, you can use these constructor syntaxes. In this way, the JavaScript shell can more or less faithfully handle all of the data that comes out of the database, and allow you to input more or less all of the data types that you're likely to want to store in the database. I say more or less only in that it appears that the arithmetic operations that are available might not preserve numeric type information. In any case, the main idea is that MongoDB actually traffics internally in a binary representation, which we call bson. The bson representation supports the basic data types that MongoDB contains. The bson specification incorporates all the types that JSON can contain, plus a few more. And the Mongo shell, as well as all of the drivers that can talk to MongoDB, support the various data types that bson supports, in some way or another. Okay, let's have a quiz. Which of the following types are available in bson? Strings, floating point numbers, complex numbers, arrays, objects, timestamps.